For the test wrapper, I decided to do problem 4 on the last exam because that's where I got the least amount of points. So we see we have a straight wire and we put a compass on top of it and it deflects an angle of 8 to the west. So in order to solve the first question, part A, it asks to find the conventional current of wire. And to do that, we use the right-hand rule. So deflection of the compass is the magnitude, and it goes to the west. So using the right hand rule, I is going to go down. So for A, I is going from north to south. In part B, we're asked to calculate that the magnitude of this I, conventional current, and to do that we can solve for it through the magnitude of the wire. So B wire equals mu naught over 4 pi times 2I over R. And this formula can be found on the equation sheet. Since we know that on our figure we have the wire and we have the compass, sorry I draw really bad, and it deflects like this, and we have I going down like that, we can use the equation that B wire, and this is the magnitude of the earth, so B earth, and we see that makes a straight angle, and then this is the angle theta. So we can use also this formula is also on the equation sheet, and it equals B wire equals B magnitude of the earth times tangent of theta. So you plug and chug in those numbers and you find on the equation sheet that the magnitude of the earth is 2 times 10 to the negative 5 teslas times tangent, and like I said earlier, we have an 8-degree deflection. So put it in the calculator and it equals 2.81 e to the negative 6 Tesla. In the second part, we're going to do the plug and chug. So we need to put everything, we need to solve for I, so we just need to put everything on the other side. So I is going to equal B wire times R divided by 2 times mu naught divided by 4 pi. The reason I left it in this form is because our equation sheet gives us this value, so it's just easier to keep it in that form. Oh, I can't forget the magnitude since we're doing magnitudes here. There we go. And our little vector errors. So we plug and chug those numbers. B wire, like we found earlier, is 2.81 e to the negative 6 teslas times R. And in the beginning, it was said that the compass is centered and placed above 4 millimeters above the wire. So that's going to be our R. So I have to convert the 4 milliliters to meters. So it's 4 times 10 to the negative 3 meters divided by 2. And on the formula sheet, mu over 4 pi equals 1.0 e to the negative 7. Plug it all into the calculator and you get 0.0562, and it's amperes because it's the current, so I. So that's how you solve for B. In the third part, they asked to figure out, let me turn the exam sheet, figure out which one of these figures demonstrate the current that is placed near a compass, and this current that is placed is a running current, a loop current, is going to be placed next to the wire in the first problem and just make it increase angle of deflection of 16 degrees to the west. So this again I had problem with, and it has to do with the right hand rule. And so since it is going clockwise for C, like let me go back. I thought it was D, but it's wrong, because if you take the counterclockwise, it would be that the current is going that way. I would be going that way, so it would cause it to be deflection to the east. Whereas in C, it's clockwise, and so I goes in that direction, so it would make it deflect to the west. So the correct answer is C. And that's all. Thank you.